All right, guys, so as we start Unit 6, we're going to start by talking about two basic ideas of geometry, which are how to find the perimeter and area of a particular figure. So we're going to talk about the main figures today that we'll see. We'll get into some more complicated cases later on into this unit, but for today, we're just going to kind of keep it with the basics. What I would really recommend you do, if you have any note cards lying around, is to make note cards for each of these different figures. And on one side, to draw the figure, and on the other side, to give the perimeter or the area. So let's talk perimeter and circumference, because circumference is, in essence, the perimeter of a circle. But when you want to look at the perimeter for a figure, if it's a rectangle or square or parallelogram and so on, then you're just going to take 2 multiplied by your width plus 2 multiplied by your length. Or in a more general sense, remember that the perimeter is just the sum of all of the sides. In other words, just add all of the sides together, and then that will be your perimeter. So what I would recommend if you are going to create these on a note card is to go ahead and draw the figure on the left side and then to write your perimeter formulas on the other side of the note card. And then I would recommend that you do the same thing with circumference. Circumference is just the perimeter for a circle. So when we want to find the perimeter for a circle, we say that the circumference is equal to 2 pi r. In other words, take 2 multiplied by pi multiplied by r. Or what you can also do is say that your circumference is equal to your diameter multiplied by pi. Remember, pi is that number that goes on forever. It is approximately 3.14159, and so on. Obviously, it does not stop there. But what we are going to do is we're going to leave all of our answers in terms of pi. So you won't actually ever multiply by 3.14. We're just going to leave it as pi in our final answer. So that's it for perimeter. Really, those are the only two things with perimeter and circumference. With area, we do have a little bit more to talk about. So the area for a rectangle is you take your length multiplied by your width. Now for a square, very similar. You would just take one side length multiplied by the other side length. So really, you could think about it in the same way. It's still length multiplied by width. However, you could also more simply say that it's just taking your side and squaring it, which is also the reason why we say that you're squaring a number is because it comes from this idea of a square. And then for a parallelogram, again, same kind of idea. You're just going to take your base multiplied by your height. So again, those first three formulas kind of go together. Again, if you're making a note card for each of these, what I would recommend doing is drawing the figure on one side and giving the formula on the other. For a triangle, in order to find the area of a triangle, your area is equal to 1/2 your base multiplied by your height. For a trapezoid, what we do is we find the average of your bases. So we take base 1 plus base 2 and divide by 2, and then multiply that by your height. So in other words, find the average, then multiply by height. And finally, for a circle, area is equal to pi r squared. If you are given the diameter instead, remember, just divide that by 2 to get your radius r, and then you can use this formula for area, which is pi r squared. So with these first 4 examples, what we're going to do is we're going to go ahead and find the perimeter or circumference if it's a circle, and then give the area for each of the figures below. We're first going to identify the figure, and then we will use the correct formulas in order to find the rest of this information. So on this first example, with our 2 side lengths being the same, that is our clue that this is a square. So for the perimeter, we just add up all of the sides. Now for a square, all of the sides must be equal to each other. So the perimeter would be adding 8 to itself 4 times. So 8 plus 8 plus 8 plus 8. And when you add all those together, you end up with 32. So your perimeter for the figure is 32. And then let's make sure to include our label. Our label in this case is feet. Now, when you get to your homework assignment, I believe on Canvas, the labels will already be in there for you, so you will just have to type in the number, but just be careful of that. Make sure that they are in fact there for you, because if not, you will need to type those in. Now for area, remember the area for a square is to take your side and square it. So our sides were length 2, or length 8. Let me go ahead and correct that. Length 8, so that would be 8 squared. And if you take 8 multiplied by 8, that is 64. So the area of our figure is 64 feet. All right. For this next example, we have a parallelogram. So for our figure, we'll go ahead and use that as our label. So parallelogram. So for our perimeter, we're going to go ahead and let's label our other side. So if this side is 11, then that means that this side is also 11. And if this side is 18, that means that this side is also 18. Now, as you can see, the height of the figure is 16. So that'll be important when we want to find the area. For perimeter, remember that you're just adding all of the sides together. So that would be taking 11 plus 11 plus 18 plus 18. And when we add all those together, they add up to be 58. This time our label is M for meters, so 58 meters. As for our area, remember for a parallelogram, your area is equal to your base multiplied by your height. So in this case, our base is 11 multiplied by our height is 16. And when we multiply those numbers together, we get 176. And our label is meters squared. So whenever you are finding the area, your label becomes squared. In fact, I think I left that off, so let me go back to the square and make sure that for area that says 64 feet squared. All right. For our next figure, let's go ahead and take a look at it now. So for our figure, we're taking a look, and this one's a little bit confusing because it doesn't look exactly the same as it did up above, but this is in fact a trapezoid. So for a trapezoid, remember for perimeter, once again, you are really just adding all of your sides together. So that would be 19 plus 21 plus 27 plus 16.5. And when you add all those together, you get 83.5. And this time our label is centimeters. For the area of a trapezoid, remember what you're going to do is find the average of your bases. So take base 1 plus base 2 over 2. And then multiply that by your height. So in this case, base number 1 is going to be the 27. Base number 2 is going to be the 19. We're going to divide those by 2 and then multiply by our height, which, let me go ahead and fill in the height as well. That would be the 16. So here are your base 1, your base 2, and your height. And then really at this point, probably the best thing that you could do would be to just type those into your calculator. And when you do, you should come up with 368 centimeters squared. All right, for our last example on this side, we're going to go ahead and take a look at a circle. So let's go ahead and find all those values for that. So with the circle, remember that our circumference is equal to either 2 pi r, or in this case, it would probably be easier to use the second formula, which is to take your diameter multiplied by pi. Since we already know the diameter is 26, so we would just plug that into our equation. So 26 pi, and then actually at this point, instead of trying to multiply it by the number for pi, which is 3.14, that's actually just going to be how we leave our final answer. Now remember your label is still yards, so we'll go ahead and put that at the end, but 26 pi yards is your circumference. Now, let's again kind of think about what would make sense as far as a real world problem. If you're trying to find the area of, let's say, the middle of a basketball court and it was 26 yards, or even better, let's think soccer field. You've got that circle in the middle of the soccer field and you're trying to figure out what is the area or the circumference of that, how far around is it, then you're probably not going to want to know 26 yards or 26 pi yards. You're probably going to want to actually know the decimal to get a little bit better idea. And so if you do type that into your calculator, 26 multiplied by pi, which again, 3.14159, let's go to two decimal places, is about 81.68 yards. But again, what you want to be more focused on is the exact value. And again, the 81.68 yards is really just if you were doing this as a real world problem, and you wanted to know the actual decimals, okay? But for this class, we're going to leave everything with pi still in it. Okay, so we'll do the same thing with area. For area, remember the formula for that is pi r squared. Now, the problem is right now we don't have our radius. We just have our diameter. But remember to get the radius, so if we want just kind of the distance from the center of your circle to the edge of your circle, that is 1/2 of the diameter. So if you take the diameter, which is 26, and divide by 2, we'll find out that 13 yards is our radius. So now we can go ahead and plug that into our area formula. So you'd say area is equal to pi multiplied by the number 13 squared. And 13 squared is 169. So that would be 169 pi. And make sure to include your label, which is yards squared, after it. So there would be the area for your circle. Now, once again, just like before, obviously that's how we will be leaving our final answer. But if you wanted to find that as a decimal, so maybe now you want to know how much is the area in case you were going to paint inside this circle or maybe something like that, then obviously you can still type that into your calculator. You're going to find that it's about 530.93 yards squared. But again, for this class, we're going to leave it with pi in our final answer. Okay, so that's pretty much it. We are going to do a few more examples. If you feel comfortable already, I would still encourage you to go ahead and continue watching these examples because there are going to be some new ones. For example, we're going to be looking at triangles. We're going to be looking at semicircles and stuff like that. So don't think that that's everything. But what we are going to do is we're just going to focus on area for these last few examples. So let's go ahead and do that now. So we're going to find the area for each figure below. For the first one, our figure is obviously a triangle. So for a triangle, we're going to find the area, which is 1/2 the base multiplied by the height. In this case, your base is 15, your height is 22. So that would be 1/2 multiplied by 15 multiplied by 22. And again, I would just recommend putting all those into your calculator. You're going to get 165, and then our label was meters m squared. All right. For this next example, notice that we have a rectangle. It's not a square because remember, for a square, you'd have to have the sides equal to each other, but you at least have all four angles as right angles, so we at least know that it's a rectangle. So remember, for a rectangle, your area is equal to your length multiplied by your width. So our length, it really doesn't matter which one we pick to be length and which one we pick to be width. I'll just let length be 4, and I'll let width be 11. So our area would be equal to 4 multiplied by 11. And so our area would be equal to 44. And that would be with our label, which was kilometers, km squared. All right. So for our next triangle, let's go ahead and figure it out as well. We're going to be using the same formula as before, but we need to be careful with what we use as our base and what we use as our height. So for base, that's actually going to be this 29, which is right here. And then our height, which is all the way off to the side, it's actually not inside the triangle, but outside, and that's going to happen sometimes, is going to be 14. So as we plug those into our formula, we'll have 1/2 multiplied by 29 multiplied by 14. and again, just recommend typing those into your calculator. You're going to get 203. In this case, our label is inches squared. All right. For our next figure, we are looking at this, and it ends up being a parallelogram. Again, the reason why you'd be able to say that this is a parallelogram instead of a trapezoid is that these two sides are the exact same. And if you weren't sure, then you could actually just use the formula for a trapezoid, and you'll actually end up with the same answer. Because it turns out that the average, when you add your two bases together, ends up still being 13, so you actually end up with the same answer. So if you're not sure, just use that formula for a trapezoid, and then you should be good. In fact, that formula for a trapezoid would also work on squares and rectangles. So if you really just wanted to remember one formula, and I don't know that I would want to do that, but the one for trapezoid works pretty much all the time except for triangles and circles. But anyways, let's go ahead and take a look at our area. So our area is equal to taking our base of our parallelogram multiplied by its height. So base is 13, height is 7.1. So the area is 13 multiplied by 7.1. And when we multiply those together, we're going to get 92.3 for our area. And then remember to include your label. In this case, that is inches squared. Okay. Two more examples, and then we're going to take a look at a couple word problems, and that should be it for today. So in this next one, we've got our figure, and in this case, we would normally say circle, but it's only half of a circle. So when we have that, it's going to be a semicircle. Now remember, the area for a typical circle is that you take pi r and square it. But now if we want a semicircle, we really only want half of that. In other words, to take that and then divide it by 2. So that would be pi r squared, all divided by 2. So a new formula, actually, for a semicircle. So you might kind of put a star by this one. If you wanted to make a new note card, you could make one for a semicircle, or just remember the one for circle, and for semicircle, divide by 2. All right, so let's plug in our information. Really, the only thing we need is our radius, which they actually already gave to us, was 16, and square it. And now we'll just look to simplify. So when we do so, 16 squared is 256, divided by 2 is 128, and then we'll put pi after it, and then we'll include our label, which is feet squared. Now, again, that's how we are going to leave our final answer, but if you were curious to see what that was as far as a decimal, it ends up being about 402.12 feet squared. So again, this is going to be how we'll leave our final answer, but if you were curious about the decimal, that's what it should be about. All right, one last figure. Let's go ahead and take a look at it. So on this last figure, obviously the sides are not the same right here. So we are not going to be able to call this a parallelogram. Instead, this is the more basic version, which is a trapezoid. So for trapezoid, we're going to be looking at using the formula, which is the average of the bases. So base 1 plus base 2 all over 2. And then multiply by your height. Now this is a kind of tricky example because your trapezoid is on its side. So your bases are not 5 and 9. Instead, your bases are your 13 and your 7. And in order to find the bases always have to be the same distance apart, which if you notice, 7 and 13 are always the same distance apart from one another. That's not true of 5 and 9. There are some places where you are further apart. So when you're trying to find the bases, find the two sides which are always the same length apart from one another. All right, so let's go ahead and add those together. So we'll take 7 plus 13, divide by 2, and then multiply that by your height. And again, that height is your distance in between those two sides. And that is the 5 millimeters, which we had right here. So that's going to be our height. So now we'll go ahead and see what that gives us. Turns out that becomes 50, and then we'll make sure to include our label, which is millimeters squared, after it. All right. That does it for the examples where we have the figure. We're now going to look at 2 examples of word problems where we can use the information to solve for a missing part. So on this first one, it tells us that the area of a triangle, or a triangle has an area of 27 square yards. The length of the height is 6 yards, and we want to find the length of the base. In order to do that, let's go ahead and first just write down what the formula is for the area of a triangle. So the area of a triangle is equal to 1/2 its base multiplied by its height. Let's go ahead and then label the information we're given. So we're told that a triangle has an area of 27 yards. So we know A is 27. And then we know the length of the height is 6 yards. So 6 is going to go in for H. So if you plug those into our formula, we're going to have 27 for A is equal to 1/2 the base B multiplied by your height, which is 6. Then we'll go ahead and simplify what's on the right side. So we'll take the 1/2 multiplied by the 6, which is 3 multiplied by its base. And now to solve for B, one last step to go, which is to divide each side by 3. And when we do that, we're going to get that 9 is equal to B. And then we just need to make sure that we include our label. So our base is equal to 9 yards. So pretty easy. It's really just a matter of pick the right formula, plug everything in, and then solve for the missing variable. So let's do that same thing on this next example. It tells us a trapezoid has an area of 60 square feet. The lengths of the bases are 6 feet and 9 feet, and we want to know the length of the height. So for a trapezoid, remember that the formula for that is the area is equal to base 1 plus base 2 all over 2 multiplied by your height. The information we were given now was that it had an area of 60 square feet. So area A is 60. The length of your 2 bases were 6 feet, so that'll be base 1, and 9 feet, that'll be base 2. So if you plug all of that into our equation, area A is 60, which is equal to base 1, which is 6, plus base 2, which is 9, all over 2, multiplied by your height. Okay, so now let's go ahead and simplify what's in the parentheses. 6 plus 9 is 15, and that divided by 2 is 7.5. So 60 is equal to 7.5 multiplied by your height. And now to get H by itself, we just divide each side by the number in front. So divide each side by 7.5. And you're going to get that 60 divided by 7.5 is 8. So 8 is equal to H. And then we'll just include the label with that. So H would be equal to 8 feet. All right, guys, that is it for this first section. In the next section, we'll talk more specifically about areas of circles. So we're going to look at what do you do if you want to find an area of just a piece of a circle rather than the entire thing. Until then, have a great rest of your day.